My name is Ashish Mahabal, and I'm going to be talking about the best programming practices. This is the first part of that. The best programming practices, there are many generic ones in that, but they also depend a lot on which programming language that you use, which package that we use, and so on. We'll be seeing some of the general ones, and then we'll try to go into details of only a few specific ones. Some of the things that you need to remember are, first thing, your code divides the universe into two. And if the code is good, then it is going to lead to a better universe, and that is what you should try to do. And that is one purpose of telling you a little bit about some of the best programming practices. And this will be not about just the programming language, but also some related aspects of that. And the best practices related to programming begin not with the program itself, but in that come in very specific things like variable names, various subroutines, the structure of the program, and the evolution and well-being of the program itself. So what does one mean by that? It's easy to do coding just by instinct, use variable names that are single letter like A, B, C, or just X, Y, Z. And that is always a bad thing to do, because at the spur of the moment that seems fine, but when down the line later on you come back to that, or someone else is reading the code, then they may or may not make sense to them. And you sometimes tend to override such variables easily. So you have to be a bit careful about what variables that the names of variables that you use. And then how to write those, we'll come to that specifically. The other component, the slightly bigger component, is the subroutines in your program. Those are the most critical parts in a program because they determine the structure of a program. And coming up with proper ones for the names and the functionality is good. So we will be seeing how the structure of a function should be, what the function should be doing, how the different functions should interact with each other, and how they should be dependent and not be dependent on each other as well. And that, in general, defines the structure of a program. That then leads you to the evolution of the program, because it rarely happens that you write a program and the program stays as it is, because down the line you think of new things or bugs are reported, so you are going to go and change that, and the program is going to evolve. So when you start writing a program or a package or a module, you have to keep in mind that this evolution is going to happen, and you have to plan for that accordingly. And the well-being is in terms of the maintenance of the program. You will be maintaining the program initially, or if you are part of a team, the team will be maintaining the program. So that too has to be kept in mind. The program, the suite has to be written in such a fashion that the maintenance is also going to be easy. So there are distinct functions, there are distinct ways in which you can use the best programming practices, and depending on language that's going to be different, but one of a generic book that I can suggest to you is The Pragmatic Programmer by Andrew Hunt and David Thomas. You should definitely take a look at that. For specific programs like Python, there are some PEPs, and we'll be seeing more of that, but import this is a standard thing that you can do, and that tells you what kind of functionality that specific best programming practices can bring in. We'll also be seeing more of that. Now, before going forward with any other specific comments, one meta comment that I would like to make about best programming practices is using source code control. That is one thing that will be the most benefiting to you and your other team members. Source code control allows you for different versions to be stored. That's one of the things. And there are many other benefits, of course. So typically, a new programmer starts writing the first program, and it may be called something like myprogram_1.py, for instance. And then the program is written, it is run, something is done with it. And then when some changes are to be made, invariably the program becomes myprogram_2.py, and soon enough it becomes myprogram_3.py, and then it can be 3a and 3b, where you add some subroutines, take some subroutines out, you combine some subroutines, and so on. And soon enough you forget which subroutine had which changes that were made, and then what are the functionalities that either you took out or took in, and so on. So in order for making all that transparent, you can use source code control. And what source code control allows you to do is Multiple people can work on the same piece of code in a transparent fashion. You can keep on making changes to your program and comment it so that they all stay in a coherent fashion. And there are many different systems that get used for source code control. The concurrent version system, CVS, has been used for a long time. That problem that way has been solved for a long time, but there have been many changes and improvements that have been made over time. Apache Subversion is something that gets used a lot these days, and Git is another similar system that is used. So we'll be seeing a little detail of that, but we cannot go into more detail, but enough help is available on these at various locations. So I encourage you to look at it and use that a lot. So let's quickly look at what a cycle of such a change through source code control can look like. Here we see SVN cycle, and there are 4 words you can see there: check-in, check-out, comment, and merge. So the repository that you see at the top of the picture, that is where all the code sits. And then you decide to interact with that code. So typically, your first step is where you make a local copy of it. That is where you are checking out the code. Once you do that, then you are free to make changes to the code and then update the code, add some features, maybe take some bugs out. And when you do that, you will add comments, what is it that you have done. And then when it is time, you will want to update the commit the updated code, and that is where merging can come in, because if at the same time 2 different people are working on the code, then it is possible through something like SVN to merge the code in a flawless manner, and that is where you check your code back in. So this is the cycle that you will typically be using. Check out the code, make changes, update/commit, and which is your check-in. The cycle for Git is similar. The diagram seems slightly different. Git is a more distributed system. But again, you see there are 4 columns here. One is a workspace, another is index, local repository, and a remote repository. So what you do is that from remote repository, you can fetch some code that comes down to local repository. And then in your workspace, you can make changes to that. And through a command like the add command, you can tell Git that that has to be added to the index and that Git should keep looking at it. And then when you do a commit, it actually gets added to local repository. So you can keep playing around. Things can stay in your local repository until you push. When you push the code back, it goes back into the central remote repository. It may not be a single location, so it doesn't have to be central. It's only notionally central, because Git repositories can be very distributed. So this cycle will allow you to keep your code safe and let multiple people work on it. So if you take just one thing out of this best programming practices module, it should be that you should try to use source code control as much as possible. You won't regret that. And now many online hubs are coming about where you don't really have to have your own repository. You can use something like GitHub or Bitbucket where Git is built in. And that way what you do is that you can fork someone else's code or have your own private or public repositories, have other team members working on it. Google Drive is something similar but for general documents, so that's another thing that you can be using. Or if you want to write papers collaboratively, you can use a tool like Authoria. And if you're just interested in LaTeXing, then there are sites like Share LaTeX and Write LaTeX. Those are equally versatile in being able to write papers. So in general, again, source code control will allow you to write code in different ways, but these other collaborative tools, which are really mushrooming out there, will allow you to do more work. So now coming specifically to coding. You can start coding by instinct, that is what everyone does, but that is something that you should avoid doing. So coming specifically to variable names, there are many ways in which you can use variables. And here I have mentioned 5. You can have the upper camel case, where sometimes your variable name has multiple words in it, and you put the words next to each other such that all except the first letters of each word are lowercase. That's why in upper camel case you see U, C, and C to be uppercase. That's one way of using variable names. The second way is where you have only the first word's first letter also lowercase. So lower first letter uppercase and then other lowercase, and other words also have their first letter uppercase. Now this is, in my opinion, the best one, because the first case is Some languages use uppercase first letters for their own keywords, and that clashes with that, whereas this lower camel case doesn't clash with that. The third possibility is all lowercase, but then it loses readability, and it's pretty bad in my opinion. You could also have things that are period separated, but again, that clashes with some languages having modules which are used in that fashion, so that's again not a very good idea. Or you can have things underscore separated. That is another good thing for readability, but then if you are using LaTeX, then you may have to take special care of not using it that way, or using a sensible LaTeX reader which knows when it is a variable name that you are using. So in general, one thing that I would advise is that you should adopt a very consistent naming system. Same thing goes for loops. There are many ways in which you can write loops. There are for loops and while loops, for instance, and you should know the strengths of the language that you are using. That is another best programming practice, because that will allow you to work with the strongest points of the language. In Python, for instance, the for loop allows an else clause. So you can have a variable run so many times, but once it is out of it, the else part can also go in. Or it can work with something like dictionaries, where you have got keys and value pairs, and it will take one by one all the keys and work on that. And then you should also know how to avoid using explicit loops when the language has ways of running faster the loop. So here are some examples that one can look at. Think of this problem where you want to add all multiples of 3 and 5 below 1,000. A simple way to do that is indicated at the top of this page here. You can go from, you can let your n go from 0 to 1,000 or below 1,000, and then if when you divide it by the 3 or 5, the remainder is 0, you simply add that number, and that's what you print. So you get sums of all numbers below 1,000 that are multiples of either 3 or 5. But you can do the same thing using something like NumPy. And using modules like these, which are easy to use, makes the programming much more fun and also faster. Here what we are doing is that we are using a loop in an explicit fashion. We are using the x and simply checking whether it's divisible by 3 or 5. In the third case, we are going one step better, because here we are not checking explicitly for remainders, but just stepping through 0 to 1,000 in steps of 3 and steps of 5 and then steps of 15, which takes out those if clauses, making the program much faster. So that is essentially what you need to be able to do, using horses for courses. And so knowing all the strengths of the programming language, how to use different kinds of loops, will allow you to do that. So besides variable names and types of loops, there is also the issue of formatting. Python and Fortran, they say you have to use specific ways in writing the code, but other languages let you be more unruly, and that can sometimes lead to very bad code. But if you are disciplined enough with your indentation, with your brackets, with your braces, and with your semicolons, then your code is going to be much better that way. So the main thing to do is be conscious and consistent in the programming style that you use. And if you are that way, then you'll find that others find your code to be much better. I mentioned earlier about import this, and that came about as a poem, in fact, that was written by Tim Peters in 2004. It has 19 items in that, and I'm highlighting only a few of them here. So one of them is explicit is better than implicit, and this is specifically in terms of typecasting rather than to assignments. As I said earlier, for loops, you can use them in an implicit fashion. But when you have namespace, when you have typecasting, when you're saying that this integer should be converted to float or float should be converted to integer and so on, it is better to be explicit about that, because otherwise what could happen is that people can make mistakes there, and while reading the code it may not be obvious that that is what is happening. Then readability counts. Even if you are very clever, try to avoid being clever in your programs, because 6 months down the line, you may forget why you were being clever there, what the clever thing was that you were doing there, and so on. Similarly, when you want to do a change, many times now is better than never. If you want to add a feature, you have thought of it, it's better to do it soon rather than not do it at all, because you have thought of it. But at the same time, the next clause goes with that never may be better than doing it right now. Because when you want to implement some change, when you want to do a modification to a program, you need to put some thought in that. If you don't do that, then it's likely to cause changes somewhere else which were unintended. So rather than be in a rush, be in a hurry, you better slow down a bit, think about it, and then make the change rather than just right away doing that. The namespaces are one honking great idea. Let's do more of those. That is what allows you to keep things coherent. That is what allows you to not muddy other subroutine spaces. So you have some related terms. They go together quite well. And then if you use various different kinds of terms, very likely other subroutines, other programs are going to use the same ones, and then you'll find that one subroutine space is overwriting another subroutine space if you're not careful. So overall, this is how a modification cycle should look for any change that you want to do, any programming change that you want to do. The ones that are in the red, we have already seen that. So you check out some code, you make some changes to it, you edit the README, and then after that, once you are happy with that, you check in the code. So the part that is between making the change and check-in is compiling the program. Of course, when you make a change, you are going to see that it runs well. And then you see more things there about testing. We have not talked about tests yet. We'll come to those in more detail, but here I wanted to point that out specifically as a part of the modification cycle. So what you need to do is, suppose you've got a program here that has certain features, and on the right-hand side is where you would like to go, because this doesn't have certain features and you want to add certain features. Or this has some bugs and you want to remove those bugs and reach here anyway. So you want to go from here to here. Now, clearly, this final program will be able to do something that this program cannot do. So you should start by writing a test, which this program is going to pass, but the program on my left-hand side is not going to pass. And in the current state of the program, clearly that test should fail. You should ensure that it indeed fails, because if it passes anyway, then clearly what's happening is that you don't really need the modification that you're thinking of. Once that happens, then you should check out the code. Once you have checked out the code, then you should make the changes that you want to do. Now compile, and now your test better pass, because you have made the change, and that is why the test is going to pass now. And once that passes, then you can do a check-in. So that is where your modification cycle has been completed. And if you follow that again for all your programming changes, then your code is going to stay healthy for a very long time. This is a simple test that one can see in Python. One can use, say, the unit test module. And here we are importing unit test, and we are defining a very simple function. The function fun takes one argument, adds 1 to it, and just returns that number. So it's incrementing the input that it's receiving. And then you see the last statement of this program, which says self.assert equal, which takes 2 arguments. The first argument is the call to the function, and the second argument is what you expect that call to return. And the two have to be the same if the test passes. And that is what you essentially need to make sure of. So when you call it by these 2 arguments, it's going to return true if the test passes. You should do that every time you want to make a change. And we'll be seeing more about tests later. So with that, we come to the end of the first part of this module. Next time, we'll be looking at project requirements and various necessary ingredients of a program.